all right. So in any case, so that one, so then hopefully Matt or whoever, or maybe NJ, then take that, take what's actually in this run, because I want to have kind of a break at the time going, because we want the computer number in the case of computers, so we can figure out what's been sent and stuff like that.
Yeah.
Because the serial number has to go into there, but so I think she sent you a link to the kind of internal spreadsheet, but then it needs to get converted, and I don't think that needs to be your job. So,
Yeah.
and well, it won't be, but I don't think it needs to be your role of that.
Yeah, I mean, like I said, I didn't really look at it too hard. I just wasn't sure if it was complete or not.
Not sure either, but
But yeah, like you said,
Alright, folks, so I'm all glad you're here. We're part of our Friday speaker series, and I'm happy to introduce Dr. Jason Fletcher here. He's the Villas Distinguished Achievement Professor of Public Affairs, and he has appointments in Applied Economics and Population Health Sciences at the University of Wisconsin. And he just got to rotate off serving as director of the Wisconsin Center for Demography of Health and Aging. His areas of expertise include health economics, economics of education, social genomics, and child and adolescent health policy. And then more specifically, his work focuses on examining social network effects on adolescent and health outcomes, combining genetics and social science research, estimating long-term consequences of childhood mental illness, and examining how in utero and early life conditions affect later life health, cognition, and mortality. So with that, I will turn it over to Dr. Fletcher.
Thanks, Karen, and thanks for having me. So I've got recent or past work, and Karen outlined some of this. And one thing I wanted to highlight is that before I was the director of our aging center, starting about 5 years ago, I really did nothing about aging and mortality. It's only been the last few years that I've turned a little bit, and so I really dug in. But which is to say, maybe unlike a lot of speakers, I'd be very willing and interested to hear if I'm saying something you think, no, that's not right. I know this paper from blah, blah, blah that you probably haven't read about mortality, especially early conditions of mortality, because that's what I'm going to focus on. So I really invite that, maybe unlike other times I've presented where I might not invite those type of questions or comments. I really do. Because I do have a set of acknowledgements who Alberto and Josh in particular serve this role a bit, but have not signed off on everything I'm going to say. So I could still be getting some things wrong. I'll highlight Hamid, who's a recent postdoc at CDHA that has really been a fabulous collaborator, and as you'll see, has been super productive in generating some of the results I'll describe. And then Josh Shin is just now a couple weeks into a postdoc at CHA to work on these questions. You've seen slides like this. This is just for the uninitiated, the main point that I want to raise in a slide comparing life expectancy in the US versus rich counterparts is that we're just not on the frontier. That's really the only point. I'm not going to try to explain this today. I just want to say, it's not that the US, to the extent that it's doing well, is that we're on the frontier. No country has ever done as well as we are. It's nowhere near that, right? So, but otherwise, I'm not trying to explain cross-country differences. So let's put a pin in cross-country differences for now. What I am looking a little bit more in depth is in the US and over time. This is some work Joshin has started to put together in. So David Cutler and Ellen Mira had a chapter from maybe 10 years ago that did something like this, where this is life expectancy gains by age. So first point is massive infant mortality reductions in the early parts of the 1900s, that's shown here, led to very large cumulative gains in overall, this is life expectancy at birth, in life expectancy in the US. So Cutler, I think, stops here in the 60s to say there's a lot of public health celebration about reducing the burden of infectious disease, sanitizing water, and things like that, that really helped 0 and 1 to 15 categories, and more recently, very little. You might say, and I'll show some evidence of this, there's not a lot left to do, maybe, in that particular part. And then by age, you also see some familiar midlife reduction. So that this is before COVID. You see 2019 is the endpoint here purposely to not have COVID part of the story. So there's some small, you've seen the deaths of despair literature, that like that's where that would come up. And then kind of modest later life gains in life expectancy. That's my editorializing of this slide. And especially in the recent period, 2000, 2020, like overall, it's just not really big compared to what was true 100, 120 years ago. That's stage setting. So I observe a massive slowdown overall. Possible that we're kind of exhausted some of the early life gains. We're kind of done with that. And so any additional gains might need to be later life. And later life gains, like I can point to these in particular, not especially strong. I had Xiaoshen do a calculation. So all I want you to do is the upper left on this one. I'm going to cut some of what I was going to say. And this is now the gains left that are still on the table, which is to say, holding constant everything else, if we completely solved age 0 mortality, what is the gain left? And it's that number, which is almost 0. And then if you do that with the other ages, you'll see that there's like more left in some of the others. But even in the US, going through 0 in age 1 through 14, like almost nothing left. Even if like no one died in the US between the ages of 0 to 14, life expectancy gains would be very small. The other thing that you have a valid question over is the black line, like the purpley black line, that the one that ends up being the one on top. That's the placeholder, that is completely determined by what you say the maximum life expectancy is. So however, if it's 110, if it's 120, that thing can keep on going up and up. Right now it's at 110. But this is to put in perspective, I think, like where future gains could come from if we had solved other problems. Like if we solved death of despair, if we solved something else, like these are the magnitudes of gains that are kind of on the table. That's the purpose of the chart. So still stage setting. But if you add up and focus now, because I'm going to focus on old age mortality, that over 120 years, like the magnitude we're talking about is about 4.5 years. So like that's, if we wanted to explain something, it'd be of that magnitude. And there's at least 2 classes of explanations that I've read in the literature. One is the role of, the way I'm carving it up is when is the exposure or the intervention happening as it relates to old age mortality. The when here is in older age, midlife or older age. So that would be like getting better at people not dying from heart attacks and people smoking less, but on the countervailing force being higher weights. So those are all not entirely late life things, but those are on the later life domains. But I think what's less explored, and that's the purpose of today, is I think there's a very clear reason why it's underexplored is we just don't really have the data. But now we do. What are the magnitudes of the long-term effects of early exposures? So there's 2 varieties of this. One, you've already seen a bit of early life survival being part of this story. And we've made huge, US and other places have made huge gains from sanitation and other things. But the part that's, I think, much less explored is what are the cumulative impacts, which is to say the impacts you see in late life from having different early life experiences over the early 1900s time frame. Pause for a second. Clarification. That's the target. What literatures suggest that target? I'm going to name 2. One that you're quite familiar with, I think, will be fetal origins or Barker hypothesis. That was part of the title of the talk. But the point is, I try to summarize it in half of a slide, is that is one of a critical period of development, that if shocks or exposures happen then, And only, and which is say, same shot could happen in a different part of life where it does not matter, is like the limiting, is the bookend of that argument. But if it happens during this in utero period, that it shapes your whole life in this, disproportionate way. And in that, under that claim is the way the developing fetus, in some sense, considers trade-offs that it faces between surviving immediately after birth, surviving long enough to have children themselves, and then later, which is just like bonus, right? Evolutionarily, like later doesn't matter that much once you're done childbearing, with some caveats about grandmother and grandfather effects that I'm aware of, but it's mostly like the target evolutionary would be like, can I make it long enough to have children of my own, pass my genes on, and then, but this is this trade-off about resource allocation in the developing fetus, about focusing on now versus later, focusing on surviving now versus keeping some resources or targeting resources that would only help later. So I've got some examples here about whether or not, when faced with nutrients, do I store them or spend them now? That's an example. How to set up defenses for diseases that I would have now versus later. Another resource allocation among organs, like definitely need your brain developing, but what's that going to come at a cost of? What other organs like that? And then another part of this literature is the kind of the laying down of our epigenetic signatures, where some portion of them are thought to be almost fixed during this period. There's certainly remaining epigenetic processes that happen over time, 100%, but there's some, maybe large, maybe majority of all epigenetic prints, markers get laid down during this period. That would be like the more extreme case of like it really matters for the longest time. 2 bits of evidence for it. You're probably familiar with the Doug Allman paper about when you were born as compared to the 1918-1919 flu pandemic, and then fast forwarding 60 years, what your disability rates are. So this is this jump up for those off the trend line of disability for those who were in utero during the pandemic. So that's a nice one picture version of things matter later. The more recent one from colleague Lauren Smits is using the health and retirement study data and their epigenetic clock measures and asking, so now the health and retirement study, many of those individuals were born during the Great Depression, 1930s, asking whether the economic shocks and when they were experienced, whether you were born in 1929, 30, 31, 32, and where in the US, some states had it worse than others. And this pattern is the effects of that deprivation on later life. Now you're age 70 or 80 in the HRS. Later life measures of biological aging. And so the speed of aging, the speed of biological aging. And what the reason I grabbed this picture is you see one huge elevation about when this deprivation mattered, and it's in utero. And not, I want to overstate these confidence intervals. You don't see that same thing otherwise, point estimate wise, there's a lot of noise in these measures, but that's consistent with the title of the slide about fetal origins and about how it could last your whole life. Keeping fetal origins, the other part of the literature I'm still, I'd say, gaining a little knowledge about is a conjecture around the difference between individual causes of death and processes and just your whole body aging. That aging is the thing, and your cause of death is just describing where at a point in time you were the weakest, not that you were strong otherwise. And so that has, I mean, if this was a reasonable framework, I think has a lot of things to then think about our focus on causes of death. And at the same time, I've read different analyses of targeted interventions on breast cancer or targeted interventions that reduce mortality on another specific cause, where in those analyses, they also have tables of all-cause mortality from those interventions. And those all-cause effects of the self-selected ones that I found are all like 0, which is to say you save breast cancer causes of death, but in the population, the all-cause mortality is not budged at all, and you're not gaining population longevity from those. That's an extreme version of this point, that if it's aging, if it's your whole body aging and deteriorating, that cancer is just one of the things that you might die from, and if not that, something else. You can have one other. These papers point out, these books, some of these are just our books, point out the enormous number of decedents who die of Alzheimer's or some other illness and have tumors, you know, as during autopsy, that, you know, but for the Alzheimer's would have potentially caused death in the next year or the second year. What do we need to extend Barker? I mean, the short answer is it's not the HRS. HRS is too small. I think what we're looking for, going back to the target, in 120 years, we had 4.5 years of life expectancy increase. So a sample of 10,000 people in the HRS targeting a specific early life shock might be way underpowered to find such a thing, if the effects are actually modest, which is to say not 3 years of life, but maybe 6 months of life or 1 month of life. This is a kind of reverse engineering this slide, what we're finding in a whole set of papers, that all our findings are of the size that we think the HRS and many other data sets could never find. That's a speculation. We have not done these analyses in the HRS. The other data issue, so you need big data on the decedent side, on the people side, but you also need elements of big data on the early condition side. And the other constraint you face is that as you think about deaths that are occurring now, or in the year 2000, you need to rewind time by 80 years to figure out what the early conditions were. And you really run out of data going back in time. So those are like these dual answers to why there's not already like 100 papers doing exactly this. Okay. Questions or anything to raise yet? Or, yeah.
I'm not sure if this is the right time for the question. You could put it to the end if you want, but I think another piece of data that you would need to confirm the fetal origin hypothesis is, you know, that hypothesis is that if you have this exposure in utero, let's say, or a critical period, anything else that happens in the life course that might reverse an adverse exposure doesn't matter, has no effect. And so you also would need the data then to determine those intervening mechanisms that could perhaps negate, you know, that hypothesis that this exposure lasts a lifetime. And for so long, there really has not been those data. You know, if you really need the longitudinal, even in HRS, you know, there could be a complete reversal of the environment, you know, in birth and early childhood that you cannot, you know, examine in HRS. So
yep.
I don't know if you thought about that, but
I thought about it in one specific direction, which is I think it really puts our finger on many things, but one thing is a claim and how credible the claim is of truly critical periods,
right.
Which is to say, like the counter to this is doesn't matter.
Right.
All kinds of environments happen later, not during critical developing periods, and like the relative effect is going to be so small. Like that's it's not really defense. I wouldn't call it just a defense, but if it was the fact, then it would be. If that was true for developing humans, then that data is less valuable. Still valuable. You'd want to know.
Sure.
And we have one paper that tries to do that, where we have essentially one experiment at birth and one experiment later life, and ask whether those two are synergistic or not. But that's a hard. I'll describe the case in just a minute because it's such a narrow case, and that is easy or straightforward to do. That's actually this last point. Ideally, you'd be able to take advantage of naturally occurring variation in like the suite of methods from the social sciences that aim at mimicking RCT type approaches. That's going to always be what we're going to try to mimic, and we'll we'll have variation in how close we think we're getting across different projects. And we'll skip here, which is, I think it's mostly restating with a couple sentences what I just said, like as you move back in time, data thins out. And after seeing the results from some of our work, I look back at the HRS and say, man, you really can only get, you're really searching for silver bullets there. Not for all health processes. I mean mortality and longevity. I don't mean like all health, but that's my ongoing opinion. Could be changed. So Josh has been making publicly available. Let's underline that because this is a major choice he made about bringing all this to the RDC or allowing everyone in the world to download it on his website. So he made the public use version of this, and that created some limitations with the data. But let me describe the data. So if you Google Sensoc, it'll go straight to Berkeley and you can download it today. What you would be getting, so the main point is it's the 1940 full count census with names, released 10 years ago or so, merged with death records. And death records could be from Numident or death master file here and here. So that's like the main baseline or the main framework, the main data structure of columns 1 and 2. The third column is not linked to 1940 census. It's just like all the death records with some minor X's with some. So I'm not going to show you any results of that third. It's just to point out it's there and it's a huge number of people. And we're going to focus on, so these are people have to have been born before 1940. We're going to focus typically on cohorts a little bit younger than that because they need to be old enough to then be swept up into the death records too. So there's like dual truncation problems in all these data sets. And some next steps is, so, the 50 is now available. I think by early next year, 2024, it'll be swept up, again, public use swept up through Josh's data set. And he's also getting more recent mortality. So those are two directions that the data are going to get better. So that's a little bit more of an advertisement for the data. But why it's useful for these analysis on the Barker stuff is we have these birth cohorts, and in some instances, we think we've got some interesting early in utero and early environmental measures from these historical time periods in the US. And then we can do this exercise of fast forwarding, 70, 80 years. And typically we'll be trying to find instances where we can use off the shelf new diff and diff literature where we have what we hope is mimicking natural experiments or RCTs. So this is the highlight Hamid, who's worked so hard in the last couple of years. This is a subset of all the papers he's led, but it gives you where are we looking in one slide. So anything from, there's lots of things happen public health wise in the early 1900s, and we're tracking down sources of when some cities changed, had water filtration and other cities didn't, and so on. And we're going to walk down, or we've done all this list, and I'm going to just focus on one today, just to give you a sense of the types of analysis that he's been leading. So that's just the kind of the titles. And then this slide is what all our findings are so far. And I'm going to kind of walk you through a couple of them to get a sense of what he's led. So the first 5 rows are not in utero exposures. These are more benchmarks from the more general literature of life course measures or events and how they relate to old age mortality in these data. As an example, row 1 is dad's education. What's the relationship between having a more highly educated father and your own life longevity as the child of that father? In this case, we're making use, well, we've got 2 of these. What I have on the slide here is we're making use of the genealogical structure of historical censuses where we can compare you and your dad's education with your cousin's father, who is your dad's brother. So it's those 2 families. And we can ask whether if your dad compared to your uncle went to a school further, did you survive longer? So that mouthful is then that estimate, which is 3 to 4 months. Using that strategy, you get 3 to 4 months out of this cohort. We have a separate, I think it's about to be submitted, where the earliest compulsory schooling laws were from the most of them were from the late 1800s. So now we're back in the business of my father being affected by compulsory schooling laws in the late 1800s. How does that affect my longevity? And it's about 4 to 5 months. That's still ongoing analysis. Birth order, that's a little bit more self-explanatory. It's just like within families, so brothers, one's born first, one's born second, which one lives the longest? It's on the order of 2 months for lower birth orders. Late life income, the example there is if you were born in 1917, when you got to be an older adult, the Social Security, I think I got all this right. The Social Security Administration made this change in benefits that cut off strictly at the birth cohort of 1917. Yeah. When you were in your like 65 years old, you got less money if you're on one side versus the other. So it's on the order, we have it in units of $1,000 in late life. If you were just sent extra, yeah, I've got it in the right direction, extra dollars because of the Social Security law that was unanticipated. It's about 1.5 months. Again, you know, getting some of these orders of magnitude all in a row. College expansions. In the 1920s to 1940 period, a lot of colleges arose in the US for using, if you were 16 years old in a county that is going to have a college in 2 years, because of this expansion across the country, you get, so it's just if you're 16 years old in that county, you have 0.2 months longevity. If you go to college, if you're one of the ones who are who moved into college because of this, then it's a year. That's now kind of a big number. You still probably couldn't get that actually you cannot get that in the HRS, but like you could imagine you could get something like that. Fertility is a new one, is using gender composition of your number of kids, and it's true back in these days as it is less true now, that having same sex for birth order 1 and 2 elicit a higher likelihood of having a third child. So girl, boy is encouraged by having 2 girls first instead of girl, boy. You don't have a third kid. Same thing, boy elicits a third kid more than boy, girl. That's the instrument, that experiment in nature. Fast forward the rest of these people's lives, and you have a 5-month reduction in longevity if you give birth another time for a woman, 3.3 months less if you're the male partner of that. And on and on. So those are to benchmark. None of those are in utero effects. Those are all like things that happen in people's lives, and those are benchmarks to some of the in utero things that we're doing. So this is like lead in water systems. We know 761 cities when their filtration system came online. If you were born when it's online versus before, you have this amount, 1.6 months longer lives. And then over here, this column, in some cases, we're powered to show bigger effects for some groups than others. We can typically do by sex, by race, by household SES in some cases. So, which is to say it's 1.6 months overall, but Black in utero experience of Black children who become adults and live their lives are more like 4 months. I'll scoot down to prohibition during the early parts of this last century. If you were in a county that became dry because of a local effort, and you fast forward the rest of your life, you are 2 months, you have 2 months of higher longevity. We do a back of the envelope treatment on the treated, which is to say, most pregnant mothers aren't drinking, some are. So this should affect those mothers who were drinking. So that's a small fraction. That's where you could get this jump up in among those who changed their behavior because of prohibition, then you get this larger effect. Ooh, boy, that's a lot. So I'm going to go in detail on one case, the pesticide case, but all these, you could ask me for any of these papers and I'd be happy to send them. Let me take another breath and see if there's questions about like what I'm trying to convey from all these, 15 or 20 papers.
So for the alcohol prohibition, how do you determine which mothers were drinking and therefore life effects?
Yeah. That's right. This is like but this is very much a back of the envelope. So Hamid found rates of women's drinking from the time, and that's the very so that gives you a kind of a max of how many could have stopped because
Okay.
Right. So, but you're right. So ideally, to fill in the detail you're asking for, ideally we'd have information.
You have the HRS ahead, asking about drinking papers just then.
Right. I mean, you can see so many conflicts here about, well, who could report that? It's not the
Right.
fetus.
Right.
So it's a hard thing to find. This is very much back of the envelope, that particular one. Yes.
Just a data question. So you have, are these all based on the 1940 census?
They're all, when you say based on, they're all
Well-
based on these data.
Right. So you
Which is to
know where
say-
somebody lives in 1940.
Yes.
You know the
And
household size and you know back.
you can then start linking them back. I wouldn't say
Because
that
you have 30, 20, 10,
yes,
and you by name,
yes.
you link them by name and residence or.
Let me, I do not want to appear like I take any credit for the linking part. So
Yeah.
there's 3 different groups across the country that I can think of offhand that all have done incredible work on machine learning algorithms of where the output is the link.
Yeah.
We're just grabbing those links,
Yeah.
going to 1940 and then moving backward in time depending on what project that we're wanting. So in some cases, we don't need to go back in time at all. In other cases, we want to see where this child who's 10 in 1940 was born, and then we're going to try to find that family in 1930, for example.
Right, but the linking identifiers are really just name, right?
No,
What else is there?
I think you're asking about the algorithm.
Yeah, in a way.
It's name, place, age would be the or birth year would be the most likely. These 3 groups do it different ways, is why I'm saying there's not one answer to your question, but those are the key elements. Some groups add in other features. Depends whether you want to allow people to change sex or race, for example. Those could be features to link, or you wouldn't want to, if you want them to not, you get the point. If you don't allow people to change those fields, then you make those decisions. We do not make any of those. We just take those links from either Princeton group census linking project or the Abramsky group at Stanford. Depends on the project. Other questions about data construction? Some of it will come up with the example that I want to go to, but let me come back to this. Is there anything I could clarify about what's going on in this table? So a lot of I've been corrected to say modest or not. These are just the sizes of the effects that we're finding, as compared to the 4.5 years of life expectancy across 120 years. At first, I was always calling them like modest and small, but people said, don't, that's not correct. These are non-trivial compared to what the whole amount could have been. Yes.
And so the months and years that you list there, that is life expectancy,
Post 60, it's most of the time going to be 65 plus, longevity past those 65 plus.
Okay.
And I should have said this earlier. I color code, red means negative. I used to have them all in the same color, and I had to say it, but red is meant to say those are treatments those are exposures that we expect that negative. So because someone had asked, if these are all positive, you can explain all 4.5 years by just kind of adding them all up in some sense, but that's not the way this is working. So let me dig into one case. Another picture I meant to say, this is Madison, in the glorious summer days at Madison, is to try as best we can to get an implicit, indirect measure of pesticides. We're talking about the early exposure to pesticides. We're talking about the early 1900s. There is not a data set that tells you anything about whether an individual was exposed to pesticides as far as we can see, as far as we found, searching for ideas about that. That'd be great. But this slide is to say there was a lot of pesticide use at that time. A lot of the banning of these pesticides is way in the future compared to 1910, 1920. Let's skip that and say what we're doing is taking from an excellent paper by Charles Taylor for a very recent time period, where he made the observation in this paper, a couple observations about cicadas. First is that time-wise, it's really clear when they're going to emerge. They're on these year cycles, 13, 17 being typical ones, but not only those. Which is to say, from our point of view, we want to know when they're occurring and where to get at, well, who was in utero during those cicada emergences. Okay, what else are we using? Cicadas at the time were mostly fended off with extreme doses of pesticides. Third fact is that they only damage some crops and not others. They only damage tree crops like apples and not row crops. So it's not like all farmers are affected or all farm workers are affected. It's those who are in places with apples, not corn. You probably already get where I'm going, that those facts, going way back in time, the cycles they emerge from the same places over time in the time period we're talking about, give us a map of where this is happening and then when. We know like every year which counties have a cicada event, and then whether that county has apples or corn, right? This is Josh's data, one of them. We start with the count. This is your question. We know everyone's county of residence in 40, then we go backwards for whenever the cicada events were happening. We need to fill in what counties these people were in before 1940 if they've changed. And then Taylor, the author of this study, gave us the historical cicada data. So it's really straightforward once you have those things in mind, I think. So you're looking at the longevity of people who were in utero in places in time that there was a cicada emergence, and we're going to further distinguish, in order to capture pesticide, whether those places were apple places. And then we're going to eventually further distinguish based on the census whether you were from a farming household in an apple place, in a cicada year in place. Okay. So if you were in a county that was an apple county during a cicada event in utero, it's 2 months loss in longevity. Orders of magnitude. If you were in a farming family in that same county rather than a non-farming family, it's 10 months of reduced longevity. So a caveat that that probably some of you were going to ask about is that we cannot fully, definitely not fully, and maybe only partially, separate two potential explanations. One is pesticide being doused on apple trees that affects the fetus. And a second one is apple production, heavily decreasing, losses of income in the area because of the cicadas. And both those two things could have lifelong longevity effects. The only thing that we've done so far, because we've certainly been pushed on this, and I'm not sure if we can do any better, is to further compare households who are farm laborers and farm owners, and the full effect is farm laborers. This is not definitive, But farm owner, if you're a child, if you're an in utero child of a farm owner and the cicada year in an apple place, then you're back at the 2 months as like the full population, this 2 months figure. It's those who are in utero in a farm laborer household in an apple place in a cicada year that you get the whole 10 months. That's where we say the 2 months is our intent to treat, like just being in that county. The 10-month is this treatment on the treated. If you allow us to go through the using the father's occupation and say it's pesticides, then we do some calculations on how many people that is, and then how many lives lost for this one event. And the point of this type of analysis is then to then be an input, potentially, we have not done this would be for someone else, to be an input of, well, this is a tiny bit of all the pesticide in the country at this time. Why don't we start thinking about scaling up the actual pesticide exposures that all our cohorts have been exposed to, and then getting at like not 55,000 years, but maybe many fold increase in the impacts on longevity for cohorts 65 years away, right? A long time away. Yes.
Did you compare in utero exposure to like young child or?
Yeah. I would say yes here. I think of a counter case where there's a couple cases. Actually, I'm gonna this slide is my next slide is the right one to say this, that in most cases that I can think of, it's certainly always disproportionate. Is it always zero outside of in utero? No. This case is going back to 1918 influenza, and instead of the in utero Doug Allman thing, it's doing 2 extra bits. So since Doug Allman's paper 15 plus years ago, there's been more other people, not us, have gone back in historical vital statistics and constructed a set of cities death rates by influenza. So you can examine doses across some cities were hit harder than others. And we examine not in utero here, but childhood impacts. If you were a child between 1 and 5 and then 6 to 11, then your late life longevity was reduced by about 8 to 10 months. That's the only time so far that we really saw something kind of big for a childhood exposure that I can think of.
It just struck me that you could use that design for any age, right?
Let me answer that a little bit more directly. We do that for every age, and it's that we don't find other ages, effects on other ages typically. We're not always powered to say something really precise on every age, but in many of these cases, certainly in the cicada case, we examine other ages, and we don't find anything among young children. It's the in utero one that's the big spike up.
And that I guess I don't understand the biology of it enough, but I assume that's supporting the Parker hypothesis that.
It does. I don't think it rules out. I don't think we could say we rule out exposure at age 2. Again, the target here is like longevity after 65. Whether there's a persistent effect, you have to survive to be old here. Once you're old, does it further affect your longevity? That's the type of effect that we're examining, and we do not find those effects for these other ages that you're asking about for the types of exposures I've listed. Yes.
Have you made any effort to sort of link up siblings and do fixed effects
Yes. Let's see.
for the pesticide? I was thinking.
Oh,
I mean, it could be for anything, but it just seems like for these kind of targeted shocks,
yes.
that could increase your precision.
I would say, so we always try, I will say that, as I start sending you these papers upon request, you'll see that they're all like 70 pages because Hamid has,
Amanda, words.
because you can do siblings
Okay.
and not always,
Yeah.
but often. You should always be interested with these data on sex differences because women are harder to link in this time period. So you're always worried about linkage issues, and
Right.
in Josh's 2 data sets, one of them is men only
Right.
for that reason.
Yeah.
So there's always a question of what about sex differences. I mean, we always try to examine it. Sometimes we don't have a lot of power. Like the birth order is within families, and so that is siblings.
Yeah.
I'm going to say that we tried siblings here and that they were uninformative, and just in the sense that the number of people in the data that we can, so this is another like linking problem that we can, so you take two people who are siblings, there's a question of whether you can link both of them into the death data.
Right.
And this is probably a comment from a comment I should have said earlier, like the linkage rates, I would call the off-the-shelf linkage rates for all of these data, you know, Princeton, Stanford, are on the order of 20%. We always have tables in all our papers about whether our treatment seems to affect the likelihood of being linked, which is a concern. I'd say we typically do not find that because linkages are really about like common names versus uncommon names and things like that. But 20% is a fact to have in our minds.
Yeah.
That is, I will say, in the future, we just had Joe Price at UW to give a talk to showcase what he's doing. He is taking the 1850, 1940 censuses, as are the other people. He's sitting on top of a genealogical tree from Family Search, and his match rates are, he reported his match rates to be on the order of 65%. I mean, it's not, I'm really simplifying what he's doing. This is years of hard work. He employs 60 RAs. A lot of handling. So like go see Joe Price's website for just to be blown away. But the match rate, so I would say all our papers adjudicate the match issue by asking whether our exposure variable affects the likelihood of being matched. I think, and that's a good thing to do. Future, we're just going to have less of a problem because we're going to get 70% matches, and that's going to be that's going to affect our likelihood, our sample sizes, right? You know, in all these cases, especially if we're trying to link two siblings, right? It's not 20%, it's 20% times 20%. If we try to move them backwards in time, then you're going to fail again 80% of the time. So even if you start at 7, 8 million, you do start losing sample rapidly because of all these linkages. Yes.
I kind of like, excuse me, I had like a basic question about one of the first tables that you showed. And you had like life expectancy gains for like age groups.
Yes.
Like, does that mean like people who died within those age groups?
It's the gain in life expectancy. Maybe okay. Your question is it? So it's a gain measure. It's as compared to before 1900. The additional life expectancy in that among those in those age groups. So like this gain is infant mortality reductions.
Gotcha. Okay. I get it now. Yeah, I just didn't understand it.
And one thing, I mean, this is new to me too, so I'll just make the point that part of not having anything here is that so few people make it there that, you know, what interventions are going to make a huge life expectancy change way back in 1900, if very few people make it to 80. So that is going on here, that you know, to get to age 10, you have to have survived to get to this one level, you have to survive the level before it and so on. So that's an interesting, you know, thing to point out. I'm just pointing that out because had many discussions about it recently. So back on the summary slide, and then it occurred to me when I was looking at these magnitudes that, so I had done a paper 8 years ago now, where I was trying, so this is a compulsory schooling affecting education, affecting later mortality point, that there were some papers prior that tried to do this using HRS, and it was really noisy. Because the HRS data are small, and so I went to a data set called Diet and Health Study, which was like 400,000 people compared to the HRS, and I sliced it because compulsory schooling laws in those times were really targeting low levels of education, so like all the college graduates are less relevant for this exercise. So I got down to 150,000 people, and I asked this compulsory schooling education question, my mortality result is 0.07 with a confidence interval of 0.08, which is to say, even with a sample size that's many times higher than the HRS, just kind of out of luck, I think. And I think this is, restating this point of which of any of these effects sizes could we get from anywhere else besides like administrative data. The thing about our vital stat system, which would be the other place to go because it's millions and millions of decedents, is that your X's about these people, there's like nothing there. You have state of birth often. That's kind of it. As far as like, well, where were you in utero? You can get states sometimes, most of the time, but not always. But you're kind of out of luck. So that's the other big data set just sitting there, but it's not very relevant for any of these, almost any of these analyses. So reminder where we were, and then I'll summarize and see if there's any other questions. So our orders of magnitude life expectancies that I've shown. My initial reading of the literature on explaining these life expectancies post 65 are that that we have medical interventions. They're great, in some ways, and they're great at some of the threats that we face as an older person, like heart attack, accidents, trauma to your person in an accident or in a fall. Pretty good at a lot of those. But so many of our chronic illnesses seems like we have not solved how to increase lifespan among those who have those risks, which are all of us. So I think that's like the task is, well, certainly we want to do more on the intervention side. I'm not schooled to know if there's a lot of promise there. Presumably other people would be very optimistic. One thing I want to do is just ask this question, well, how much of all what we're seeing in terms of increases in life expectancy at older ages could plausibly be traced back to this fetal origin phenomenon? And so that's the list of effect sizes that I've shown. Now, and it faces these problems I described. You have to go back in time, run out of data. You have to make do with cicadas when you want pesticides, right? And do that a lot. We're going to keep on doing that. We haven't started yet impact other big name impacts in the early 20th century, World War I. There's a bunch of other laws. There's other sources of disease environments that we're thinking of. I did mention this to Kathy earlier in response to one of her questions. There's one thing that we've tried to do so far is take the late life income. So again, that's the Social Security Administration saying, okay, you guys, you're 65 and you were born January 1st, 1917 versus December 1916. Those two people got two different amounts of money. So we interact that with all these things in another paper to ask the joint influence of like bad or good things happening in early life with cash infusion in old age. And that's still forthcoming. So it's on our radar. This is not going to solve the problem. I would not say that we'd see, oh, it's all about complementarities. It's all about like getting early life and late life. That's going to get these big effect sizes. That's not what we're saying. I think there's kind of marginal changes, but I would say they're mostly kind of independent effects so far. That's the one case that we can definitely do. We're still searching for more, complementarities that we might look at. So I think we're still, wanting to further examine this target of how much of recent changes in life expectancy among older people is this long shadow, especially of the in utero environment. And I think what's super interesting is, we've gone way back in time and thought about the environment then. To the extent you don't think that looks like our early environment now, right? There's a lot more to do in piecing those things together. Like how much pesticide is there now compared to before? Is it a lot higher versus a lot lower? And on and on, like all the things we've done about income shocks. We still have income shocks, right? Prohibition, that's not for these days, but we might have solved some of these problems with clean water, but not everywhere. right? So what are the new set of in utero conditions now that we're laying out that are going to affect life, going to affect longevity in 65, 70 years from now? I think that's like a really open and very interesting like next step. So I'll stop there and ask for any other questions. Well,
I think the whole effort is very impressive. The data preparations, the results. And I have a general question. So how special is the caseta pesticide? So that era, full of pesticide, right?
yes.
We use pesticide to kill mosquitoes, to kill bed bugs, and every farmers use lots of them. That has to be really special. Otherwise, why is it so outstanding, right? Why it stands out relative to the other?
You mean
They have to make
relative to mosquitoes and stuff?
And
So
yeah, you have to make the assumption that everything else, this is really special.
oh, I thought you were going a different way. I thought so. One answer to the comment is that if pesticides are pesticides or pesticides, we just have the exposure of pesticides have the same effect. We're just trying to isolate a context where we think that we're getting causal effects with the caveats I said. We would not turn away anything that you were describing about mosquitoes if there was data and research design that would further support this analysis of linking those things. So
But
the
the
question
fact
is,
is more relative to the people who did not do the apples. But those people also subject
Yes.
to other pesticides.
I'll underline your point. This is
Yeah.
just the net against a background of pesticide, right? This is just that net to say, I think this is like an existence point of, is there a long-term effect of pesticide exposure on late life mortality? Maybe.
But the assumption has to be made that the apple farmers subject to a special amount of.
No. It's just the net, whatever it is, whatever amount it is.
But what's
what we're
the
picking on.
comparison group?
In years that there's not cicadas, it's the extra amount induced by cicada emergence against the backdrop of like always spraying your apples for pesticide. It's the extra dosing that happens because all these things are going to kill your apple trees, and you really want to dose them.
But the other people in the comparison will have to subject to all the other pesticides, right?
100%. Yeah, the control group here is also
Yeah.
pesticide, swimming in pesticide. This is the extra that we can focus on. That's right. Yeah.
Correct me if I'm wrong, but didn't you mention heavy metals were used in the pesticides, like for the succeeding years? Like, I guess I'm not super like knowledgeable about like what kind of chemicals are used as pesticides, but maybe perhaps like that may be related to what he was saying was that these, I don't know, specifically to kill the cicadas, like had a lot of heavy metals, and perhaps like that was increasing like the difference for
That's
the
super interesting. So I don't know if I don't think we found that. That's
Okay.
100% worth finding.
And what about the people that were consuming the apples, like in the surrounding areas, like not just farmers? Like, was that kind of the comparing between farmers and non-farmers? Was the other people that are consuming, the local marketable?
Those are
apples?
part of our control group. This is, against the backdrop of everyone has pesticide exposure. It's that extra bit. So you're right. It's not going from 0 to this amount. It's like lots, and then this is more. But great point about this heavy metal thing. We haven't looked at that yet. First in the yellow.
So this is really interesting, and you've spent a lot of time on really interesting exposures, and I was kind of wondering about the outcome. So the
Yeah.
mortality is sort of
Now
all
here's the downside of the data. You have one outcome.
well, it's all cause mortality.
Yes.
But
yes.
what about looking at causes of mortality that have been linked more closely to developmental origins? So looking specifically at heart disease or cardiometabolic disease mortality, for
So
example.
that remains on our to-do, and the constraint here, as far as I understand it, is the ability to share publicly the data that Josh has stops so far at cause of death, and it's all right now. My understanding is that he thinks he's going to get more years of all-cause mortality. But it seems so far that it's off the table, because the product here is public use data, right? That is off the table in his discussions with Newman and Jeff Masterfile, whichever one it is, that is this discussion, they just, no. So far, no, unfortunately. I think that we don't have any, I thought we had a fix for that, but I think the answer is no. Yeah, exactly.
A similar question. So your findings are conditional on making it to 65. What's the effect of treatment on additional years?
Yes.
What about premature death? Not making it to 65 as a binary outcome or something like that, or years less than 65?
Yes, things we'd like to know. I agree with
the data, or
so let's see. Like going backwards in time, which is the earlier deaths, there's not the data. So my understanding from Josh's perspective, as you move in period time back towards 1900, the death records are just terrible. It's overstating it. They get worse. So he's more comfortable.
so you just need to survive till 100, and then you can do the study.
That'd be a start. Yeah.
All right, we are just about out of time, but I'm sure he can stick around for a few more questions. So thank you.